Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 10, which is all about polynomials and quadratics and factoring and stuff like that. Today's lesson is 10.3. The name of this lesson is Special Products of Polynomials. Our essential question on this note sheet is, what are special products of polynomials? All right. So you should know how to FOIL, or in better terms, to distribute. So why don't you go ahead? There's basically what we're talking about today is when we multiply a couple different binomials together, there's going to be a pattern, okay? And it's an important pattern for factoring that we need to identify. And so we're going to kind of work backwards here. Instead of going from factoring and what you're going to learn about later. What we're going to do is we're going to distribute, and we're going to see what the end result is going to be, and then we'll know that end result for later when we want to factor. We'll know, oh, if it's going to factor, it's going to look like this when we distribute, okay? All right, so go ahead and see if you can distribute these first three problems here and see what you get, and see if you can come up with a pattern. All right, let's go through this now. So we have x minus 5 times x plus 5. Well, x times x is going to be x squared. X times 5 is going to be 5x. Negative 5 times x is negative 5x. Negative 5 times 5 is negative 25. Okay, so after we distribute, we want to combine like terms. Are there any like terms here? Yep, we got 5x and negative 5x. Ooh, what's 5x minus 5x though? What does that go to? They cancel out. That goes to 0. So what we're left with is x squared minus 25. Interesting. Okay, let's do another one. We have 4m plus 7 times 4m minus 7. So 4m times 4m is going to be 16m squared. 4m times negative 7 is negative 28m. Then we do 7 times everything in the other parentheses. We have 7 times 4m is going to be 28m. And then we have 7 times negative 7, which is negative 49. Oh, look at this. We combine like terms again. Negative 28m plus 28m is going to cancel and go to 0. And we're left with 16m squared minus 49. Okay, looks like we got it to cancel again here. Look at our answers here. So we had x squared. We got it from minus 25 from x minus 5 and x plus 5, and we got 16m squared minus 49 with 4m plus 7 and 4m minus 7. Okay, see if you can figure out the pattern here. Okay, let's keep going. We have 8 plus 5x times 8 minus 5x. We're going to do 8 times 8, which is 64. 8 times negative 5x is negative 40x. 5x times 8 is 40x. And then 5x times negative 5x is negative 25x squared. And lo and behold, look again, negative 40x plus 40x is going to go to 0, and we're left with 64 minus 25x squared. All right, so every time we do binomials being multiplied like this, you're going to get the same kind of pattern, all right? So some common characteristics. There are going to be two binomials, the original problem. And one binomial is going to have a plus and a minus. Do you see how we have a plus and a minus here? We use red. We have minus and plus, we have plus and minus, and we have plus and minus, okay? The answer each answer has a what? Look at the answer here. What's in the middle of all these? In the middle, we have a subtraction symbol. Each answer has a subtraction symbol. And how many terms do each of these answers have? These have 2 terms each, which is called a binomial when we have 2 terms. And we're going to cross out what they have here and kind of put this. We're going to cross this out and we're going to write. The trick is that we're going to have the middle 2 terms. The middle 2 terms, I'll write terms again. The middle 2 terms are going to cancel. So remember we had 5x and negative 5x. These are going to cancel all up here, okay? So the middle 2 terms when you FOIL, or the O and I in FOIL, I guess, if you want to use the FOIL method, or just the middle 2 terms when you distribute everything, you're going to have those are going to cancel out. Okay? So what's the pattern? This is called the sum and difference pattern, or difference of squares is how it's written. The result is written as a difference of squares. So if we had, it's going to be a plus b. This is just a general kind of formula here. We had a plus b times a minus b. What's the pattern going to be? Well, if we look up here, if x is a and 5 is b, we got a minus b times a plus b here. What is x squared? If x is a, what's x squared? Well, that's going to be a squared. So it equals a squared. And then if b is 5, what is 25 going to be? Well, that's going to be minus b squared. So that is the pattern. That's the sum or difference pattern. This is called a difference of squares over here. And a difference of squares is going to factor to a plus b and a minus b. Okay, or when you multiply a plus b times a minus b, the middle terms are going to cancel out, and you're going to be left with a squared minus b squared, okay? And since you only need to use, let's see here, the a squared and b squared terms. We're going to cross this off and put terms. Only need the a squared and b squared terms, okay? So that's kind of a shortcut. All right, try the shortcut. See if you can do this pattern. Figure out a and b, and then find a squared and b squared, and see if you can come up with a pattern here. Try 1 and 2. All right, so we have y plus 11 times y minus 11. So I like to write what a equals and b equals. So what's our a? Our a is y, our b is 11. Because it's a plus b times a minus b, right? A plus b, a minus b. All right, that's what we have here. So if a is y, what is a squared going to be? Well, that's going to be y squared. And if b is 11, what's b squared going to be? Well, it's going to be 11 squared like this, which equals 121. So our final answer is going to be y squared minus 121. It's got to be a squared minus b squared. Okay? So that's all you have to do. If you can figure out that pattern, you don't need to do any other extra work. You can just do y squared minus 121, and you're good to go. If this is a struggle for you, though, feel free to keep, foiling or keep distributing until you get the pattern down. It will become automatic after a while, but if you can see it right away, that's the best. But I know it is still a little bit tricky and kind of abstract at this point, okay? Let's do the next one. All right, we have 7 minus 2m times 7 plus m, 2m. So we need to find our a and b. So a in this case is what? A is going to be 7. B is going to be 2m. So if a is 7, a squared is going to equal what? What's 7 squared? We'll go like this. 7 squared equals 49. And if b is 2m, what's b squared going to be? Well, that's going to be parentheses 2m squared. So we got to do the 2 to the 2 and 2 to the m. So it's going to be 4m squared. So our answer is going to be a squared is 49, and then minus, and then our b squared is 4m squared. So if you were to FOIL this entire thing over here, it's going to reduce to 49 minus 4m squared. We're skipping the middle steps by distributing everything and just knowing what the pattern is going to give us, okay? All right, sounds good. So we have another pattern we need to talk about. It's going to be what's called a perfect square trinomial is what the end result's going to be. So we have these problems here. We have x plus 5 all squared, 8 minus 3m all squared, and 6x plus 5 all squared. What does this squared mean? What does this squared mean? How many x plus 5s are we multiplying together here? 2, and we're multiplying 2 8 minus 3m's together and 2 6x plus 5's together. So I'm going to go like this. We're going to do x plus 5 times x plus 5. And then we're going to do 8 minus 3m times 8 minus 3m. That was really sloppy. I'm going to fix that. Okay, and we're also going to do 6x plus 5 times 6x plus 5. Okay, so now that we know what that is, I want you to go ahead and distribute all of these and see if you can come up with a pattern. So you're going to distribute and combine like terms, and you're going to try to see if you can come up with a pattern. This one's a little bit trickier to see, but if you see it right away, that's awesome. If not, we're going to go through it. And just be aware, it looks like this is the same kind of problem, but it's going to be a little bit different because these are both positive or both negative. These are both positive or both negative. Okay, so it's not going to be the same exact thing, so just make sure you're careful with that, okay? All right, let's go through this now. So we have, I'm going to get rid of these. You won't see these circles anymore. I just circled the addition and subtraction symbols. All right, let's go ahead and distribute this. So we're going to do x times x. What's x times x? Well, that is x squared. What's x times 5? That is 5x. What's 5 times x? That is also 5x plus 5x. And 5 times positive 5 is 25. Okay, what are the like terms here? We got 5x and 5x. Well, it's actually not going to go to 0 this time. What's 5x plus 5x? It's not 0, it's 10x. So we got x squared plus 10x plus 25 is our final answer. Okay. I still see the x squared in the 25, but that 10x is a little bit kind of hard to figure out. I wonder what the pattern's going to be for that. But let's keep going. Let's keep doing a couple more. So we have this one, 8 minus 3m times 8 minus 3m. So we have 8 times 8, which is 64. 8 times negative 3m, which is negative 24m. Negative 3m times 8, which is negative 24m. And negative 3m times negative 3m is going to be what? That's going to be positive 9m squared. All right, now what's that going to reduce to? Well, we're going to have 64. Negative 24 minus 24 is going to be negative 48m plus 9m squared. So again, I see two perfect squares. I should have mentioned before, there's perfect squares up here for this is difference of squares. There are two perfect squares, a squared and b squared. Same thing down here. We have two perfect squares. We have x squared and 25 are perfect squares, 64 and 9m squared are perfect squares. But the middle term is kind of a little bit weird, like what that's going to be. But see if you can figure out what the pattern is for that. We'll talk about it more in a second here. Last one, here we go. 6x plus 5 times 6x plus 5. So 6x times 6x is 36x squared. 6x times 5 is, 6x times 6x is 36x squared. 6x times 5 is 30x. 5 times 6x is another 30x. 5 times 5 is 25. All right, when we combine like terms, we're going to have 36x squared. 30 plus 30 is 60x. And plus 25. All right, so can you see the pattern here? Where are we getting 60 or 10x and negative 24 or 48m and 60x? Well, we'll get through that in a second. If you saw it, that's awesome. So we'll see if we can define it a little bit more here, okay? So each problem is a binomial squared. A binomial squared, for example, like 2x minus 3 squared, that's a binomial squared, right? The problem can have a plus or a minus for these problems. Now, what's our answer? What are all three of these answers over here? What do they all look like? How many terms do they have? They have 3 terms, which is called a what? It's called a trinomial. Okay, it's got 3 terms, which is a trinomial. And the middle term is going to be double. This is the part that's tricky. It's going to be double the middle 2 terms when you're distributing, okay? So that's the tricky part, is the middle term is double the middle 2 terms multiplied together. Okay? Well, let's see if we can do a couple pattern here. So here's the pattern. So it's going to be, let's see here. So we have a plus b all squared is going to equal, here's the pattern, a squared plus 2ab plus b squared. And then a minus b squared is a little bit similar, except it's going to be a squared minus 2ab plus b squared, okay? So, so basically you're still going to square the a and square the b, but the middle term is you're going to double a times b, and you're going to put that in the middle, okay? So the shortcut for the answer is to square each term in the binomial, and then you're going to double the a times b of the terms in the binomial, okay? All right, let's do this. Let's figure this out here, okay? So we have 3x minus 5 all squared. We need to find a and b. Okay, what's our a? Well, a is 3x. What's our b? Our b is 5. Okay? So that means we need to find a squared and b squared. So what's a squared? Okay, so that's going to be 3x all squared, which equals what? 3, it's going to be, or 2 to the 3 and 2 to the x squared is going to be 9x squared. And then we need b squared. Well, what's 5 squared going to be? It's going to be 25. So that's the first and last term. Now let's find the middle term, okay? So you don't always need to write out this stuff that I'm writing here. This is kind of to get in the process of doing it, but you can literally just do it. Well, the second one we'll do really quickly, and I'll show you what we mean, and then I'll do it the long way too, okay? All right, now we need to find double a times b. So we need 2 times, well, what's a? A is 3x, and b is 5, right? So double, what's 3x times 5? Well, that's 15x. And what's 2 times 15x? Well, that's 30x. So now we have all of our terms. We have 9x squared, 25, and 30x. So it's going to be 9x squared. And it's actually, I goofed something up here, actually. It's negative 5. B is, let's see here. Yeah, it's going to be negative 30x because there's a minus sign right here, okay? So it's 9x squared minus 30x. and then it's plus 25. And there's your final answer. If you were to distribute this and expand it out, do 3x minus 5 twice, like this, and you can still do that. Like I said, you're still going to get the final answer of 9x squared minus 30x plus 25. Okay, we're kind of doing a shortcut. All right, let's do a little bit trick. I'm going to do the second one with a shortcut, like a super shortcut, and then we'll do it the long way too, okay? So, what's a in this case? What's a in this case? We have 2y plus 7 all squared. What's a? Well, a is, let me write this out. We have a plus b all squared equals a squared minus 2ab plus b squared. All right, so if a is 2y, what's a squared going to be? That's going to be 4y squared. Okay. What's b squared? Well, that's going to be 7 squared. That's going to be 49. And then what's double a times b? Well, a times b is 2y times 7. What's 2y times 7? That's 14y. And what's double 14y? It should be plus there. Double 14y is 28y. Okay, so that's the way you do it the quick way. Okay, but the long way would be to go a equals 2y, a squared equals 4y squared, b equals 7, b squared equals 49, and then double ab is going to be 2 times 2y times 7, which equals 2 times 14y, which equals 28y. Okay? So you can do it the long way like I did right here, or if you just get in the habit of going, oh, a squared is this, b squared is this, and then double these two multiplied together, that's going to be kind of the sweet spot. Okay? All right. Is that all we have today? I think it is. All right. Thank you for watching. Have a great day, and we will talk soon.